The similar logic. So how the page rank of one web page will be calculated? So here, page rank of the web page U. Okay, like so here, assume that PR stands for page ranking. Okay, like page rank of U. U is a web page of any page. It need not be web page or any page that you want to rank. Okay, so PR of some page U equal to sigma, and I know that all of you have some mathematical background, right? So it's just like sigma indicates summing up, okay, like summing operation. PR of V, okay, like divided by L of V. Here, anyway, we know that it is a page ranking. Okay, like a page rank of V indicates that like any page which is linked or which is available on the web page of U, or which is linked from you. Okay, and L of V, L indicates the total number of links available in U. Okay, L means the total number of links. PR means okay, like page ranking. Suppose a given page has okay, like 10 links for other pages. So obviously, like you would go to that page, and then like from there you would go to other page like that, right? So if you're going from one page, okay, like so, if one of the pages linked in that page, okay, like has some page ranking, obviously the parent page which has this link also added the page rank of all your child pages. Okay, like that's how the page rank would be calculated. So for all the pages which are linked in the page U, okay, like so that is that's why V belongs to okay, like B of U. Here B of U is something like a set of all the pages, okay, like linking to page U. So from whatever the pages that you would go into the page U, okay, for all the pages, page rank of each page divided by okay, like how many number of links of that page. Okay, like so this is how you calculate the page ranking in short form. Okay, like or in a what is like in a scientific form or in a formula. Okay, like this is the formula that it will be used. Okay, like to calculate that form. It's not a I mean, maybe it has all the sigma divided by page ranking, and obviously like page rank of U is sigma of all the pages, page rank of V by L of V. Here, obviously, you might have understand by this time. This looks like some recursive, is it not? So if you want to calculate of the page, you need to see first. You need to calculate all the pages linked to that page, right? Then only that you could calculate that one. Obviously, it looks like same recursive manner. Okay, like so. Unless I have a page ranking calculated for all the pages, I cannot calculate it for the parent page like that. Okay, like so that is why this algorithm is suitable. Okay, like for distribution, the computing, and that's why in MapReduce it became a famous. Okay, like so people would use MapReduce methodology. Okay, like to calculate page ranking because it allows that one. Okay, like one by. There is a small set. Okay, like you calculate the page ranking for that page, and if there are inside any links, again you go to the recursive manner, calculate the page ranking of that one, and then like submit up all the stuff. Okay, like until you hit the parent page. Okay. So page rank value for page U is depend on page rank values for each page V contained in the set B of U. Here the B of U is nothing but the set contained all pages linking to page U. Okay, and then divided by number of links from page V. Okay, so this is the formal definition of page ranking. First, we need to. I'm trying to make all of you okay, like familiar about what is this algorithm. What is this algorithm? Then we will see that like how we will write the same algorithm, how we would transform into a MapReduce program. Okay. let's take a small example. Okay, like we have a um, the network of 4 pages. Okay, 4 web pages called A, B, C, and D. Okay, like so, page rank of, and here the self linkage. Suppose if the page A is being linked to the same page A in any of the places, so we are being ignoring the self links. So let's assume that like A has links from B, C, and D. Okay, like just for our simplicity, okay, like to make ourselves understand it much more clear manner. Okay. So now the page rank of A, okay, like equal to, since it has links from B and C and D, okay, like so the page rank of A is nothing but page rank of B divided by link of total number of links are available in the B plus page rank of C divided by L of C plus page rank of D divided by L of D. Because we are here, we in this example we have only the network of only the 4 pages, and the page A has been linked from BCD. That is the assumption. So if you calculate the page rank of page A, okay, like this, page rank of A equal to PR of B by L of B plus PR C by L of C plus PR D by L of B. Again, there may be small variations, okay, like in online tutorials or in somewhere, or maybe in the Hadoop books. You may see little bit variations from that, but even I looked into some of the pages, but this is very I mean, when you follow this algorithm of this format, okay, like PRV of LFB, then it is much more close to the real page ranking algorithm, and also it's very easy to understand in this manner. So that is the reason I'm more focusing on this content. Of course, I also lifted from one of the tutorials. Okay, so this is what like simplicity. Page ranking of A equal to page rank of B by L of total number of links of page B plus page rank of C divided by total number of links of page C, page rank of D divided by total number of links of D. Okay, this is how calculated. And some variations, okay, like the same page ranking, okay, like so what they do is same a small what do you call a noise reduction factor. It's called like a dumping factor. Okay, like so to make it much more smoother, to make it what do you call it, to remove the residual, okay, like of summing up all these numbers. Okay, like so what they do is, okay, like they calculate this dumping factor. Typically they start with the value of like 0.85 as a dumping factor, and then 1 minus D divided by the total number of pages or total number of documents here. Total number of documents here, it will be 4. Okay, plus the dumping factor multiplied with all the page ranking of all the pages, okay, divided by total number of links. Then they multiply with that one. Some websites or some what do you call it? In some books, okay, like they define the page ranking like this as well. So there are 2 variations. You could do that one, like one way to another. Frankly speaking, there are like 10 different variations of page ranking algorithms are existing. Okay, like so. Here, our goal is not to implement that algorithm, okay, like to rank the pages, but to understand how this algorithm, okay, like we could write using MapReduce. So that is the goal. That is the reason I don't want to confuse you by explaining more variations of this algorithm. But this is the first one. Okay, like it's very simple. PR of A equal to PR of B by L of B plus PR of C by L of C plus PR D of L of D. Okay, like so this is one way. And same algorithm, okay, like so to reduce some of the noise, okay, like to make it as a much more what to say, like close to the reality, or close to avoid some of the residual values. So what they do is they use this dumping factor and they multiplied the dumping factor for the entire page ranking, and then 1 minus d divided by m plus d multiplied by entire page ranking, which is calculated in this way. So that will be considered as a final tune page ranking. Okay, this would be enough really. Like, so we need not look a lot of things other than this. It's very simple. I know that you all guys has from a mathematical background, so it's not a complex algorithm. Okay, it's very simple only. Okay, like so since it looked like some yeah, used very easily in the distributed computing, and then so that like you could easily make it as a MapReduce program. Some of the algorithms, not all algorithms that you could write MapReduce. So some algorithms are very, very easily you could fit into the MapReduce programming paradigm. Okay, so page ranking is one of them. Okay, this is what the algorithm is about. So once it is clear, then I will move into, okay, like suppose you have total here the four websites. Okay, four web pages. Sorry, four web pages. So 4 pages. So 4 pages. From each page, how many links are there? And from this page, whether you could go to a particular page or not. Suppose you mark here ABCD, right? We took the examples of ABCD. Okay. And then from A, okay, like whether you could go to the D, whether you could go to the C, whether you could go to the D. So if you can go to that from A to B, then they mark it as a 1, otherwise they mark it as a 0, like that. So at the input for this one would be basically for each page.
Hadoop plus.
First thing, let's, you want to see the driver, and then from the driver we could go to that one, individual explanations. Yes, maybe that would be the better way. Okay, like so. I hope the font is clear and it's visible. Let me know if you guys want to increase the font. Still, okay. page to the links of other pages. So it would be like adjacency matrix or addition matrix, okay, like in a form of metric. Okay. And output directory, it will write into the output directory because for each iteration, okay, like for once you finish all the nodes, again you will run the same. Okay, like so it's called like iteration, right? So you iterate from one to another. So that's the reason they will call it as iterate. So here in the driver program, okay, like so for for each input file, okay, like take that one, the entire input file, and write into the file again, all your page ranking, and again you could read from there, and then like you could write into back. So you could repeat this step how many number of times that you want, okay, like until it becomes stable, until you will not see any of the changes in the page ranking, okay, like so not much changes from the previous value to the new values. So until the time, okay, like you could run multiple times. So multiple times that you could run map this job to calculate the page ranking and tune the page ranking numbers further, like that. So after several times, okay, the value will become much more stable. You will not see not too much difference in the page ranking. It will be like 0.00001 like that. So until you get that thing, okay, you just iterate through multiple times. That's one. Um, so pass a file, write to a file, okay, like the same thing. And the next time you read it from the output directory. And the next time again you overwrite the output directory and then read it again, like that. Okay. First one is very, very simple and a number of nodes. Okay, like so this one will give you, here the node is nothing but a page. Okay, like so the logical representation of each page, okay, like in a Java terminology, like it will be the Java class name called like a node. Okay, like that's the number of nodes. How many nodes are there? Basically, how many pages that you want to do that from. And here, convergence. Okay, like so here they're calculating what is the convergence value. That means the difference between the previous calculated page ranking and this time calculated page ranking. And if not that, if the difference is 0.01, then you are exiting from the iterate. Until you get the page ranking values for tuning of the difference of 0.01. Okay, like so how many number of times that you iterate the same values, okay, like again and again and again. So if you're not seeing the difference with 0.01, then you are exiting from the program. Okay, until that time, okay, like you just go iterate on the same value. Defaultly, okay, like so they will assume page ranking of individual page to some value. Okay, like I think 1 or 0.85, some value that I will show you exactly where it's been running as well, where it's been setting that one. So they will assume it will be in the node. Yeah, default page ranking is 0.25 here in this program. They assume it is a 0.25. Okay, like so at the lower level page, which does not have any of the links to any other. Okay, like so that will be the uh, page rank value of that page. So 0.25. From there it will start. And then it will output what is the page ranking of that iteration. And the next time when it is reading, okay, like it will read the previously calculated page ranking for that. And again, it will follow the same way. And that it will write into the file. Next time it will read from that, like that. Until it hits the, what do you call it, divergence. Okay, like so, desired convergence, okay, sorry, not convergence. Desired convergence, here in this program, they calculate two values. One is called like a sum with desired convergence and each page desired convergence. So they'll make sure that the value is less than of this. Okay, then they will exit from it. Here you could see this one. While true, obviously while true, iterating that, okay, like inside the iterate, you are calculating or you are calling map reduce job multiple times. Okay, like each iteration, it calculates the page ranking of all the pages and write into the file. So the next time again, it will see that one. So they'll calculate what is the desired convergence. We'll see that one as well, like how it will calculate and all that stuff. Uh, these are the system of statements, not much values. Just it will indicate that like which iteration that we are running and what is my input path and what is my output path. Because for each iteration, your input path would change. Of course, output path also would change. From the iteration one, I'm considering from input path directory one and writing into output path one. For the second iteration, I will read from output path one and I will read from output path one and then write output into output path two. So the next time your input path will become output path two and then write into output path three, like that. Okay. There is one thing here. Okay, like if you observe that it's been create the input file, and then you pass the input file to your calculate page ranking. Uh, all the paths, okay, like so we know that there are, because we are looking for the HDFS mapped program, so all the paths will be pointed to HDFS definitions. File system, get number of nodes, okay, like of the file, just to read the file and then it will give you how many number of nodes are there in that. Let's see that one. Get file system of that whatever in the configuration object that you've been passed. It will read the lines one by one, open the file, and UTF-8 indicates that like whether it is a ASCII format or any other format that you want to highlight on that. And size. Typically, it will give you how many number of lines that input file has. That number of nodes, that means that each node or each page has a single line entry in their input. Okay, like that's what it is going to create in the get number. Then the get number of nodes means if you have ABCD pages, it will, so your get number of nodes should be 4. And output, okay, like of course each line it will split, okay, like, and then it will split based on what is it like maybe if I can show you that input file, that would be better. I don't have it right now. I'll show you that one. Okay, like so. Maybe that would make much more sense. Anyway, let's move to the next one. When writing to the output path file, okay, like so each one have a page number like 1, 2, 3, 4 or A, B, C, D, and then give a tab, and then like you get to the node to the string, and then put the slash one. This will give you just like how to create that file itself. Okay, like so just create the file and input file, and then you pass that. You pass that input file to the program, okay, while calculating this page rank method. The next one, how to calculate this page ranking. And inside the page rank method, okay, like so what we do is it will call the map ready job. Okay, like that is where the a MapReduce driver program would be kicked off. So for this, calling the MapReduce program will be done for each iteration until okay like your desired convergence value would be 0.01. Okay, like so, and this page ranking method okay like will return that value. That's why the return type is called like a double. It returns the um, convergence value. We'll see that one as well. Okay, like what does it what it does and everything. Um, so get instance of what is the application name, what is your MapReduce application name. Okay, like you could assign some of the application name here while defining your job object. And this will be displayed in your resource manager. Okay, like whenever you see that like MapReduce job of application or something, and this is the name it will be displayed there. Okay. Set jar by class, and we know that what is the driver class name. Okay, like that's called set jar by class. And set mapper class, what is the mapper class name? And here for some simplicity, okay, like we define as a map dot class. And reducer class is reduce dot class. And input format class, because we have been creating the file in the text format in the UTF-8, that's why it's called like key value text input format. And remember, like key value text input format is a key and then value pair. So we are this will be like a two things, key and then the value. And key and value have been separated by the tab. That's what the input format of the MapReduce program. Okay. And from the mapper, okay, like what is the from the mapper, okay, like we're writing into the text, and even the value also would be in the text. Okay. What else? Okay, set input path and set output path, and we don't worry about that one. And the next one is how to calculate this convergence value. And here in this program, they used okay like a counters. Okay, like because you have been running on this or running this program okay like multiple times, so like MapReduce it's calling that one. So each from mapper to the reducer, how many number of mappers that it got involved and how many number of reducers it got there. And these counters will always be helpful okay like to track the information. Okay, like whether it can be, you could define it wherever you want it. Okay, like but here the defines are like reduce the reducer class. Okay, like you could go and I'll come back on that one. Okay, like so, but just for the reducer class, okay, just assume that. Okay, like so, we are calculating the convergence value and summed convergence value and then convergence value, and then finally we are returning this convergence value back to the main method. Okay, like so, that is the purpose of the driver program here. And of course, this is short statements will give you exactly like how many number of nodes and what is the summed convergence and what is the convergence value. Okay. Again, after explaining everything, also I'll come back on this. But now I don't think like you could follow that. Next one, like each page will be represented as a node. Okay, like so the node class. So the node class has what are the data elements in this one. One is the like page ranking. Another one is adjacent node names. So it's a graph, right? Like each node is like a graph. So what are the nodes which has links from here? That's called like that's all the data elements. One is called like a page ranking of that node, and then adjacent node names. A field separated, anyways, tab here that's /t indicates it's a tab. Okay, like how this key value pair will be there. So this is the constant anyway. Okay, that's it's been defined as static and final. The methods, get methods and getters and setters for both page ranking and also the get adjacent names. I don't think I need to go through that. It's very self-explanatory. The one method that I am very interesting to explain is this one from MR. Okay, so if you pass some of the value, some value from from MR means from the MapReduce job. So whatever the value that got calculated using the MapReduce algorithm, using MapReduce program, and finally whatever the value that it got it, so that value would be overwrite as page ranking for that given node. That's what it does. Is. So here um, you got some value, right, which is in the string, and obviously this string has in a key value pair format. Both key and value have been separated by this tab character there. So that's why we are splitting up using this field separator. And then we got that one. Okay, like one is node name, another one is like page ranking, basically. So what are the value that we got it in that? Then that will be set as a page rank. Okay, like for that given node, and then it return the value. So always to invoke a node object, so from the external thing, so they'll be calling this from MR. From MR, and then you pass some of the value. So it creates the node object and then assigns the page ranking value, whatever the value that you passed to the from MR method, and that will be set as a page ranking, and then it will give you the default value, whatever the default value. If you don't create that one, that will be here, but it's always be set from the MR. Okay. This is about the node object. And the next one, we'll see mapper. I'll also repeat one more time. Okay, if you're not understanding any of that one, so just note it down. Okay, like anywhere, wherever it's not clear, I will repeat one more time. Okay. First one, we have the for the mapper, it's a like text context, right? Like the input format is a key value format. So for each key value pair, okay, like this will be called. So once you got the key value pair, then whenever it called, obviously the first thing what you need to do is we call that from MR method from the node, which will create a node object, which will return a node object, it will create a node object and return the same node object by setting into page ranking of that what are the value that you passed. Okay. But initially we know that what is the value. Initially it tells us that page rank value is 1 for all the pages. So 1 it will be set to the page ranking and it will create and it will give the node. And the next one, so whatever the adjacent names of that node, okay, like what are the adjacent nodes on that, okay? For each one, okay, like it will calculate, it will go to that loop and it will calculate the page ranking and PR of, remember like a PR of B, PR of A equal to PR of B by L of B, right? Like L of B, how it will get that one is, so how many addition node names are there? So that will give you the list of array. Basically, it's not even list. It's an array of the names or array of the node names. Suppose A has BCD, an array of B, C, D, and to see that total number of links to calculate L of just you get the size of that one. Such will be the same as like the length of that one. So directly get addition names and then length. So this one get addition node names will use an array object. Array has how many number of elements that will be derived from your input file and calculate the length. So here get page rank, get a dot length. So this is nothing but page rank of that node divided by how many number of total links are there. Everything together will be considered as a page ranking, and you need to sum it up all the things, right? So for every node, get I equal to 0, get addition node names, not length, obviously how many number of nodes are there. For each one, Okay, like so you calculate everything and then you do the same you do the same key and then like output from your mapper. So at the end, if you observe clearly, what would be your out key and then out value? Okay, like out key would be the node name, and the output value would be whatever the uh, node which is adjacent to that one. That is what like anything from the your mapper. Both are in text only. I said the text to text, text to text, text to text. But inside one, okay, like inside the node object, okay, you are calculating the page ranking of that. These two things are writing into writing from the mapper output. Next one, okay, this is all mapper. Okay, like just remember like what is the what are the things here it's been writing into. Okay, like from that text and text. I hope you remember like what is that meaning of this one. Whenever you are extending the mapper class, text is the input key, text is the input key value, and text is the output key tag, and this text is the output key value. Okay. And then we'll go to the reducer. Let's see what would happen. Of course, I was getting the input as text, and then it is writing text and text. We'll come back on this course. Okay, like which has that one. Okay, that's not important. Each node, okay, like how many number of links are there? Like that many number of values that we will get it from the mapper output. All right, obviously, like depending on the length of the adjacent names, that array length. Okay, like if A has the links B, C, D, then they would have like three. So for key A, you will get three entries, right? So the list will have three of them. So here, what we need to do is exactly like in the reducer. Okay, like on each page wise, we are calculating. Okay, like PR of B by L of C, L of B. PR of B by L of B is the one which I want to do is I need to sum it up all the page rankings of all the pages of a given page. Okay, so it's very simple. Okay, like from the node and each of the values of the text. Okay, like so you got the node here, and then once you got the node, okay, like so get all the page ranking of that one, then sum the page ranks. Like related to that, you sum it up all the values there. Okay, like that will be equivalent to this one. PR of B by L of B, PR of C by L of C, PR D of L of D. Okay, like so we calculated this step in reducer for a given field, for a given page. Okay. Next one is like that dumping factor. Okay, so this dumping factor here, 1 minus dumping factor divided by number of nodes in a graph. Okay, like so here 1 minus D divided by the M. Okay, like that's how it's calculating there in that in the dumping factor. So here this dumping factor would be like initially, as I told you, like here the D would be value as minus 0.85. Okay, like that is typically it will be followed. And if you see that here, the dumping factor is a constant, they defined as a 0.85 here. Okay. So you got the dumping factor, and then got the dumping factor plus dumping factor multiplied with summary page rankings. So all the sums which we calculated, okay, like you just multiplied into sum. So finally, 1 minus D by N plus D multiplied by the page ranking. So this will be coming as new page rank. Okay. And we talked about that, what do you call that, the convergence also, right? So the delta, okay, like originally, whatever thing that you are reading, okay, whatever the value that you read for for that input element minus what is the new page rank. And this delta should be less than or equal to 0.01, which is called like the convergence factor. Okay, that convergence. So if this delta is within that range, then we will stop the iteration. Then we're not going to calculate that same method. That is the purpose of that. And from the reducer, obviously, like again, you write the key and then what is the output value. So you calculate with what is the calculated value, you emit that, and key, always key would be like here, the same page. What are the page? The page numbers are A, B, C, D, and then you put out the A there. And from one to another, like from one reducer to another, or from one mapper to another, like that. So to communicate from one reducer to another reducer, like so they use the counters. To see that what is would be the what do you call this convergence scaling factor? Like to get that one, they define this counter values. Like so counter dot. Just define the counter so that like you will get to know what is the this is the enum type. Like this is the convergence scaling factor. Like so just from one reducer to another reducer, like if you want anything in common, you want to get to know value. Like so counters are one of the methods. You will use the counters. Okay. That's it. Nothing else. This is called like reducer. The only difference is from your regular MapReduce program to page ranking. Here, we will call the MapReduce program multiple times. That is the only difference. Typically, in a word count, you will call MapReduce program at once. Like you call mapper, reducer, driver. You call the driver program only at once. Like but in here in the page ranking, you will do that multiple times. Unless your convergence factor is like as expected or within that range. That is only the difference, especially in terms of the map reducers. So here, I mean, again, I'm going back to the document. Like writing into a Java map reduce, I don't think that's really a challenging thing. But you know what you need to do, how you need to divide into a MapReduce program. Logic you could write whatever the way that you want it. I don't want to bias your thoughts by showing you something and explain that one. You need to write it this way only. That is a program. Like programming, right? You could write in multiple ways. Like suppose if I ask you to display 1 to 100 numbers, I'm pretty sure like you all will come up with your own solution. I could see definitely 40, 50 solutions are there, right? To display numbers from 1 to 100, like in any programming language, there are several ways how you do that. But what is the logic behind that one? That is much more important, right? So here in this algorithm, especially while computing the final page ranking of all the pages, what you need to do is individually, like the page. Suppose here we do have A, B, C, D. For A, we do have the links from B, C, and D. So here what we need to do is, for A, you are calculating the B. You are calculating the PR of B by L of B. This is with respect to the page number A. Okay. And then we are calculating the page ranking of C by L of C, page ranking of D by L of D. Okay, like so for this key, A is the key. Suppose if you assume that like everything from the mapper, from MapReduce, everything is the key value pair, right? So from the mapper, you emit A and then page ranking of B. Emit A, page ranking of C. A and then page ranking of D. PRD by L of D, what I mean to say here. This sum. A, PRD of L of D. A, PRC of L of C. A, PRD of L of D. So there are three key value pairs emitted from the mapper for node A or for page A. And on the reducer side, for that key, okay, like you get the list of the values, three values, which is having PRB by L of B, PRC of L of C, PRD of L of D. So you sum all these three, and then you use the calculator, the dumping factor, and then like you multiply with that, and then you get this PR of A. That will not be enough. So you need to iterate again by calculating this PR of A. And so wherever it is being used is like this PR again you will call that. Finally, okay, like so what are the divergence factor that you are getting? Okay, like so it is within a range. And assume that your algorithm is working fine, and then you could exit from the iterator. Clear? Not sure. Okay. So I took one of the example. So here there are five nodes. Okay, I just went to the notation as 1, 2, 3, 4, 5. Okay, because you are already hearing ABCD a lot. So let's go to that 1, 2, 3, 4, 5. I have 5 pages. Okay. From each page, okay, like let's assume 1 to 1 is always 0. Okay, like there will be a 5 again. Okay. That's called like it's just like a matrix. Just assume that 5 rows, 5 columns, because I have 5 pages. Okay. The first one is called like a page, no, page number or page name. Okay, like and then there is a space or tab. And then I do have the values of page ranking for each page. It's for self-linking, I mean like 1 to 1, it will be always 0. Similarly, 2 to 2 is 0, 3 to 3 is 0, 4 to 4 is 0 always, and 5 to 5 is always 0. Okay. And if it has like from 1, there is a 2, 3, 4 links, and there is no 1 to 5 link. Okay, like so that is why for 1 to 2, I put it as a 1, 1 to 3, I put it as a 1, and 1 to 4, I put it as a 1. So this is the initial adjacent matrix that you need to build and then pass to the program. And from this program, from this input file, you will calculate the PR of everything, right? For everything, for each page, for each uh, for each page, where whatever the value other than 0. If it is a 0, you always get the 0. Okay, because 0 divided by 0, 0 divided by any number will become a 0 only, right? So here you could see this one. For 1, after first iteration, for example, this 1 would become whatever that is the initial page ranking that you are seeing from the input file. So once you calculate all the child pages page ranking and then sum it up and then use the dumping factor, so your page ranking will become 0.0.667. I've just given some. Maybe what I would do is let me remove all these things out there. Okay, 6.7. And this one is also 6.7. This is also 6.7. That's again. Okay, we got in a similar way. Okay. So this all the ones, that is the one only you are going to calculate for page ranking. So now the page ranking become 0.67 for the pages 2, 3, 4. So you emit from that. Okay. For the second page, similarly, you have only 1 at the end, so you calculate that and then it becomes 0.2. Some value, whatever the output from your MapReduce program. And for the 3, there is only one, sorry, there are 2 ones here. You calculate that, here is the 0.1 and 0.1 is the output. Similarly, you have other values as well. So now, after first iteration, these are the values that you have been, it's been calculated and then you've been emitted out, okay, from your MapReduce program. The reducer has second, for the second iteration, okay, like take this as an input file and then emit output file again. So this time when you try to emit, okay, like so this value maybe from 0.67 to maybe 0.75. Here 0.75. This one would be something 7.8. And this will become maybe 3, 4. This is 0.1 to 2, 3. Yes. So this is output from the second iteration. Again, you pass this one to the third iteration. You consider this value. So initial page ranking value, initial page ranking will be like 0.0 discount, right? When a first time it's starting, it will be 1. Okay, like then the output of content, then again it will go to that. So the difference between the previous one and this one, if it is 0.01, okay, like less than of 0.01, then you exit from the loop by saying that like, okay, then I reach uh, a tuned page ranking of Edgar time, okay, like much more smoother, and then like so these are the final. And then finally, whatever the output value that you got it, then you submit that value. So this is a sample example values. Of course, instead of 1, 2, 3, 4, 5, you could say that A, B, C, D as well. A, B, C, D, E, A, B, C, D, E. But these values will always be numeric. But this one, if you want, you could change that one. So here, instead of 1, 2, 3, 4, 5, I could make like page number as 5 years. Okay. Initially, if you don't give any of the values, then only it's 0.25. Normally, it will be 1 only. Okay, like from the initial input you are giving as a page ranking of each one, right? Like so that will be 1 only. Okay, like so here, I mean in my code, when you see this node one, okay, like so this one, when you don't pass any of the value, then only this will be there for everything because from MR is the only one that we are being calling, right? Like so this is how you are creating a node object always from MR. From MR is the one like which you are doing, right? So here you will pass some value only. That means you are passing some value. That value is nothing but your page ranking. Finally, that is the value that it's going to set into the page rank. Initially, it will be 1 only. Yeah, here it's really confusing. Maybe this one also we could make it as a 1. Yeah, just to make it a simple. Even though here it's defined as 0.25, but it's never been executed at all because we're not going to use these values anyway. Okay, the object of this class will always be created using from this method only. Okay, so whenever you call from this method, obviously you are getting that value and then you are setting it to the page rank. So there is nowhere that okay, like you are using the default value which is been defined here. You are always been resetting that value. Okay, very good. How to merge all the files in a given HDFS directory and get the merged file to local operating system. I given the clue as well. Okay, like how to get all the files of a given HDFS directory and get merged file into a local disk. Here my intention is maybe you guys will look for that. Okay, like are there any command for merging the files from HDFS itself? And most of the submissions, okay, like if I see that everyone almost okay, like so they use the get or copy to local. This one is good. Okay, like so most of them, and this is what really I expected. There is a command exists for git merge. But so git merge, and then you give one of the HDFS path. So it get all the files from HDFS. And in the local operating system, it will try to merge that one. But if you just get, it will not merge the files. If HDFS files has, if HDFS directory has 4 files, your get command will give you all the 4 files. And there is no merging at all. I know some of you has have challenges in running of the cluster. Okay, like I can understand that. But see here, this one is the right one. And minus NL option, okay, like it just adds a new line character at the end of each file. That's what it indicates. So when it's merging all the files together, if there is no new line feed or if there is no blank line at the end, so what it does is when it's try to merging out, okay, like it will try to merge to the previous line. Sometimes it happens, okay, like so. But here in this example, we got the file as 123 ABCDEF SCD 100, 200, 300. It's like a git merge of all the files. Obviously, like what is the directory name? Okay, like here the 14518 is that directory. Okay, like all of that files. Obviously, you will see that one. It's everything looks pretty good. Sometimes what will happen is it will try to add the first line of the file will try to add into the last line there. If there is no end of file character or something like that, like there are some chances. So to handle that cases, they introduce this option called minus ML. So it adds a new line at the end of each file output. That is the reason after 1 to 3, you will see a line blank here. And then after ABCDFSCD, okay, like you will see the blank line. 100, 200, 300, there is a blank line. So that is the purpose of this minus ML. And even my intention is that one only, like so that you will try. And this student, he tried without minus NL option, he was given that. And next he tried with minus NL option. Exactly this is what I expected. Excellent. Okay. This is also good. Okay, like so here also I'm seeing okay, like yep, very good. So that's about the GitNet thing. Of course, I will show you also like by running that command. Okay, like once my cluster is back, okay, look like it was back. One is count, another one is GitNet. HDFS looks like you guys have done very good way. Okay, like and then find. Of course, HDFS is very simple as well. And find how to find all the files matching with given pattern in HDFS. I got a lot of submissions, but surprisingly, many of them has given me that Unix command. I clearly indicated how to find out in HDFS. Okay, like some of them are tried really very good. So um, and this one and this one. This is also right answer. I'm not saying that, like, but this is not the answer that I expected. This also will give you the same answer, but this is not the right answer for the question posted there. And the LSR from root, that will give you list down all the files, directories, files, and everything. Maybe you may have a very small cluster having maybe a 20 or 30 files. That will be fine. But in reality, when I run this command, okay, like in my cluster, it will take nearly 20 to 30 minutes to give me the output because you have the millions of files and directories in which we attach. And of course, it will not give you the output at all because um, uh, you may not have the access for all the folders of HDFS, starting from the root, user level and all the things like that. I cannot view the files created by the other users, okay, like that. Okay, like that. I mean, yeah, in your sandbox, in your cluster, you could do that. This one is Unix command. And see here, I already explained that, like how to see HDFS files. Okay, right? Like so, some of you have really got a sent out a message that there is no command to find the files. I was really surprised. Um, there is a chance. Okay, like what version of Hadoop that you guys are using? Okay, like so because the find command, DFS find command is not available in the older versions of the Hadoop. So that is absolutely the right answer, or that is also correct answer, but not the good answer for the question that I posted there. That is the reason really I thought like um, one is what we thought like okay. I think we already gone through that one. HDFS DFS help will give you all the commands that it supports. Or even you need not type HDFS DFS help, type HDFS DFS and enter. This will give you all the options. We covered most of the options in the class itself. I covered the count. I covered the get merge. Okay, like the same thing I asked again. And so now count question has been posted there, right? So now what I expected is you guys will see what are these options. What does minus q will give you, minus h will give you, minus v will give you, minus t will give you, like that. So the one student is given get merge. Okay, like so he has submitted, he or she, I don't know exactly. Like so, um, submitted get merge, some source and local destination, and then also she has given minus nl and submitted both of them together. Exactly. That's what right. For each command, okay, like so see all the options, how we could see that, how we could use that one. That is how you learn, especially in the open source community. You won't see the documentation. Maybe the Google may not be able to help you out. Okay, like and it will not be listed down all the options. It will not be listed down the correct information. Maybe it might have listed down something else. Okay, like that. Uh, Give me 1 second. Okay, like I don't take much time.